Hello and welcome to this 3ds Max tutorial. We're going to learn how to run a water flow simulation. We will try to emulate the behavior of the water in a river downstream. First, you'll need to know that to run this experiment, we'll need a new plugin of 3ds Max called TyFlow. You can click it and download it for free. Also, make sure that you have set your units right. If you go to unit setups, set your metric system as desired, meters, and make sure that every unit equals to one amount of that unit. And lastly, we'll need a model, a 3D model in where we'll run this experiment. In this case, I have drawn what tries to simulate a channel. We'll count that as a water stream. So first of all, we'll have to bring TyFlow to the action. We'll do that by clicking the creation tool and go to TyFlow. Just click whatever you want in the image and you can scale this as desired or move it however you want to do that. Clicking the TyFlow icon and then clicking modify, you can click this one, open editor, and it will display a new window. In this window, you will have your new workspace where all the magic will happen. And at the bottom, you have the inputs or events, if you want to call it that way. Each of these events will have an actual impact on the model on real time. So I had already set up the TyFlow that will be running for this exercise. And I will explain what each of these inputs does to the model. So first, let's go to birth. To create one of these events, just have to click one event here and drag it there. Or the other way is just click in the workspace and press the tab on your keyboard. Then you press the word and double click, and there you have it. So going back to the explanation of these events, birth will tell us where the animation starts and where it ends. And this number here represents the amount of particles that we're going to be seeing through that time frame. We will also need to add a position icon surface. By clicking the event, clicking tab, you click position icon. That's the way you can add this one. I'll delete it because I already have it placed there. So what this will do is tell TyFlow what is the source where all the particles are going to be coming from. And to create that source, you have to go to the creation tools, click the helpers, go to TyFlow, and create a Ty icon. I had already done that before, so I'm gonna erase this one and turn on the Ty icon that I had previously done. This is the one. I'll change a little bit the viewport, go into a perspective mode so that you can see further things that we're going to be doing here. The next thing that you want to include is a shape modifier. This will actually be very important because it will let us see how the particles are going to look like. You can configure this to be seen as a two-dimensional thing or as a three-dimensional thing. In this case, I set a sphere in a low resolution for the model to run more easily. as you can see, these are the shapes that were displayed. You can also change that in the display modifier that comes already with the birth event. In this case, we are seeing the sprites, but you can also set it to small dots or geometry. In this case, the geometry is going to be the same than this one because we already set this to sphere. But what if we were to add another shape? Let's say, let's bring some teapot and go back to shape. So then if we click add selected, we can see that everything coming from this tie icon will be teapots. And as we have two, actually, as we have two sorts of shapes, this will be, this will make those two shapes be born out of the TypeFlow icon. So let's erase this so that we can continue with the experiment. By clicking this and remove, you can detach that as well. Okay, so next thing is to add a speed. Again, if you press tab, the speed, double click, and you will add the speed. It is important that in this case, as gravity goes down, we set the direction along the icon arrow. And then we are going to be playing with these parameters, but for now, the another event we should include is a force. This is a very logical way of thinking this because we need gravity sort of to attract the particles, right? So adding force will make us get that result. If by contrary, we would set the built-in gravity in a positive number, you can see that the particles are actually going up. So if you set this at a negative number, we will include natural gravity into the model. And last thing to set this is a collision modifier. I had already created that and picked the terrain as a source. So I'm going to remove this for you to see what would happen if we do not have that. So all the particles seems to pass through the terrain. So to fix that, we go back to collision, pick the terrain, and now there will be an interaction of those two elements. Okay, going back to the force, there are some other cool things that we can edit. For example, the strength of the force. So if we set this to -10, let's say, there will be a much greater force attracting all the dots into the earth. So every time I move the time slider, you will see that, let's compare it frame by frame. Let's say that in the frame 50, this particle is farther than if we put the strength to 1. Okay, so that has a direct impact on the model. Also, if you go to collision, you can edit some things like the bouncing point. Now, if you see the particles, that first particles that touch the ground are kind of bouncing. So you can reduce that by decreasing this amount. So if you set this to, let's say, 5, you will see now that there's less bouncing effect. If by contrary you would have you have more percentage to this, and if we move the Tycoon surface, you can see this more clearly. We can do this. If I drag it down, you see how they bounce, right? And if I change this back to 5%, let's say, there'll be less bounce. And this is also crucial because when we are trying to emulate water, water has many properties, and one of them is the bouncing, right? So setting this to 0 would not be so accurate, actually. So this is a good number to set this simulation. Then we can kind of moving this are setting the frame of the particles to fall right into the stream. And with that, we're pretty much set to run the simulation. As I move the time slider, I'm not getting the results I want because perhaps what needs to be done is to change the force. So by adding more force to it, I can see now the particles actually flowing downstream. So this starts to look better. Now, to add an even more realistic appeal to this exercise, we're going to add a time measure. So let's go back to the creation panel. I choose in this sliding bar time flow and choose time measure. There's the time measure. I had already created one, so I'm gonna tell you how to link this to time flow. You just have to click the time measure, go back to edit, and here you click pick and select the time flow. So there's the direct effect. This will add like a fluid sense to the particles, making them look like water. So if we run the simulation now, we're getting a better result. One thing that we can do once the particles end the circuit, you can see that they're still continue to develop, right? So what we can do is, first of all, go back to the creation panel, standard primitives, and we can create a box that we can use later as a point to erase the excessive amount of particles. Okay, so let's go here at another collision point. And with this one, we're going to pick, sorry, is this one. With this one, we're going to pick this new element. And we also are going to add a delete event. And you just have to drag this and link it to this point. So now every time that one particle touches that box, it will be erased. For your simulation, you can click this item and turn it off so that you don't see that actually. You can click this again and move it somewhere else so that it can match your model in a better way. Okay, so this is looking better now. And perhaps one last touch for this to look more like water would be to add a particle bind modifier that what this will do is tell the particles to act like water. Um, One of the things that you can edit from this is the stiffness. So if you set this to the maximum amount, which is 2, you will be telling Tyflow that all the particles should gather. And if you just press 0, you're saying that the particles should be splitted. So we're going to set this to a midterm solution, like let's say 1. We'll run this simulation again. If you're not happy with that result, you can go back to the time measure, select it, go into edit, and play with some parameters. Let's say if we're gonna play with the radius. So if we increase the radius, it will increase the amount of measure being created around every particle, okay? If I increase the voxel size, it will increase the shape that is being created around the particles. So if this number is less, for the water remulation model, it works best because actually it's not geometrical. So the less number that you put in the voxel, the better result for the water appeal you will have. So if you want to be more explorative about this type of exercises, you can also bring new elements to interact with the action. So I brought this element that could act like a wall, let's say in the middle of the river, trying to slow down the velocity of the stream. So by clicking back the first collision, you can also add a new collision point. Click this one. And now the simulation will have to stop, right? So see how the particles are now struggling to continue. And some of them are successful in their way of trespassing this new obstacle. If the particles were to be bigger, modifying those in shape, let's say that now it's 100% original size. Once the particle collide with this new object, it will be easier for them to surpass them. So this is something that you can adjust many times to get the better result. Okay. You can turn this out again, remove it. And let's say that you also want to run some simulations on new arms of the river. So I have already done that in the design, and I have drawn this, what it looks to be like a retention pond. So let's see if the water will actually follow that course. Let's click play, and there it is. You can go back and click this off again. And last thing that you would need to know is that if you want to change the color of the water, you can click the time measure, this color box, and select any color you want. And press play. And that's it. That's how you create a water flow simulation on 3ds Max using Tyflow. Thank you for watching.